All right, hello, trade class. Mr. McAvoy here. You can see, you can see that I did shave. I did keep my word. This is me without a beard, and it's very cold. So thank you guys again for all your generous contributions to Pennies for TLC. It'll be a very short lesson today. I hope everyone's doing okay. I can imagine that it's a really interesting time for you guys as me as well. I feel like I'm talking to myself as I look out into a room of empty desks, and I guess this is what it's like to be a person who films himself, I guess. I don't know. Anyways, I'd like to do just a simple, short little lesson today. It's going to be solving simple logarithmic equations. And so let's write that down as our goal. So we have something that we're going to add to our cheat sheet, and it's actually a pretty simple concept if you actually translate it and you think about what it actually means. So let's set this. Let's call this up setting up log equations. And we're going to add this to our cheat sheet. And what it says is the following. It says that if log, I feel like I'm blocking, log base b of x equals log base b of y, this is only true if x is equal to y. So we're going to have a situation like this. And very quickly we can turn it into a much simpler equation like this and solve for unknown value. And you'll see that this is actually a very simple lesson. So I'll just do a couple examples. I will also have an accompanying homework assignment. That's a good idea. The way that you're going to turn in the assignment to me is I don't know how to collect it online. So what you'll do is you'll just take a picture of the work that you did on a separate piece of paper, load that to Google, and turn that in, and that's how I will give you credit. So this is a real simple lesson, and it shouldn't take us very long to do. So let's just do a couple quick examples. So example one, we'll see an equation like log base 5 of 3x, and that will be equal to log base 5 of x plus 8. Okay. So again, we have this situation where we have the same base number. Instead of a b, they're both 5. So what that means is I can set the of numbers equal. So this very simply turns into the equation 3x will be equal to x plus 8. And this is very simple to solve. You subtract the x's to both sides. 2x is equal to 8. Divide away the 2. X will be equal to 4. So if we were to plug 4 into both of these problems, we would see that in fact we get log base 5 of 3 times 4 is 12, and that should also be equal to 12. So this side will be log base 5 of 4 plus 8 again, which is 12, and it makes sense. Again, these are very simple equations to solve, and again, what this interprets to us is what exponent does 5 need to turn into 12. And since they're equal, they better both need the same exponent to turn into the same number. And they need to turn into the same number because that's why we were able to set those equal. So this is really the main idea for this concept. Now, I can add quadratics to these, the A times C problems. And since this is a video lesson, if I go too fast and you don't quite get it, you can hit pause, rewind it. You know, you can take notes or not. I don't know how, if you really need to, it's all digitalized. I don't know if that's a word or not, but where did I have my, oh, there he is. All right, so we'll see some problems like this. Again, I had this situation, so I was able to set up this simple equation. And there we go. So let me do another example. We'll call this example 2. So example 2, it could be a quadratic. It could be something that looks like this. Log base 7 of x squared plus 5, and that is equal to log base 7 of, oh gosh, 6x. Okay. So again, I have this situation where I'm left with this, and I can very quickly rewrite this equation because these have to be equal if these are equal. So now I get x squared plus 5 is equal to 6x. And now I'm looking at this, I realize, did I write a good or bad problem? And I don't know until I work this out. So since I have a quadratic, I do need to get all the x's to one side. So I'm going to be left with x squared minus 6x plus 5 is equal to 0. Remember, in doing this, I need this to equal to 0. And so I can very quickly do the shortcut. My A times C number will be equal to 5. How do I multiply to 5 and add the negative 6? This is a positive number, so the only way that I can add to a or multiply to a positive number would be if both of my factors are positive or both of my factors are negative. Now, since my b value is negative, I know that I'm going to need the 2 negative values. So my A times C multiplies to positive 5, but the way that I'm going to multiply to positive 5 is negative 1 and negative 5. So I very quickly can factor this now to x minus 1 and x minus 5. Remember, we can only do the shortcut when your A value is equal to 1. And so I get as a value, for this, x is equal to 1. For this, x is equal to 5. So this would be how I can make a quadratic problem out of this. So I think so far so good. And again, we could check. If I plug in 1, this becomes 1 squared plus 5. That becomes log base 7 of 6. And again, that would be log base 7 of 6 if I plug in 1. If I plug in 5, now I get 5 squared, which is 25 plus 5. So I have log base 7 of 30. And then log base 7 of 30 when I plug in a 5. So both of these work. Okay. I'm going to just show a situation very quickly of when this can go wrong, and hopefully we understand what this means. Okay, so we'll move on to the last example, example 3. In example 3, I'll say log base 8 is equal to 2x, or log base 8 of 2x will be equal to log base 8 of negative 14. So again, using the idea, I get 2x is equal to negative 14, divide away the 2, and my value of x is negative 7. Now when I plug in my value of negative 7, here I get log base 8 of negative 14, and that will also be equal to log base 8 of negative 14. Now, remember, when we're looking at this, it's what exponent does 8 need to turn into negative 14? And this actually creates something that's not possible, because 8 is a positive number, and no matter what power you raise a positive number to, it's not going to turn into a negative number. So even though we got an answer to this problem, we would actually say that there is no solution to this problem, because what happens is when we plug in our answer, we get a situation that's not possible. There's no power that you can put on 8 that would change it from a positive number into a negative number. And so it's actually going to be important that we do take a second and check through the answers, because a couple problems, maybe one, maybe two, maybe all, probably not all, on the homework will have the situation arise where there is no solution. So again, I just wanted to solve simple logarithmic equations. We set up the log equations by using this simple rule. And again, just be aware of the no situation. So that ends this lesson for today. I do hope everyone out there is doing all right. Thinking of you guys, and I hope all of your friends and family are all right as well. I'll see you guys tomorrow with our next lesson. This homework assignment will be due tomorrow. And again, if you have any questions, please email me. I will be responding to emails actively between the hours of 8 a.m. and 2 p.m. Monday through Friday. So have a good day, everybody. I will post the next video tomorrow.